Did you? Hello. So today we are going to discuss about the probability distribution and how the variables are defined and how the probability distribution are based on the different kinds of variables. So we called it here, the chapter name is discrete random variables and their probability distribution. So here we wanted to discuss about the discrete random variable. So there is two kinds of variable. One is, what are those? One is continuous variable and the other one is discrete variable. It can be random or it can be deliberate or purposive, but the variables can be either discrete or continuous. Are you there?
Yes,
can you
sir.
hear me properly?
Sir.
Good. So variables are defined as characteristics that change or vary over time and or for different individuals or objects under consideration. So variables are the characteristics that changes its value over time or over space, yeah, or over an individuals or objects in consideration. That's why it's called a variable. For example, what do you think? Height is a variable. Height of an object.
Yes, sir. It can be a variable.
It can be a variable because if you measure the height of an object, of different object, on your table server, for example, you have 5 pencil, huh? You wanted to find out the length of the pencil, yeah. So whatever, how long you used it, no problem. At the end of the use, you wanted to find out that what is the average length of the pencil right now. So here length of the pencil is a variable.
Variable. Yes, sir.
So it can be qualitative, it can be quantitative. Qualitative variable and quantitative variable means a variable can be expressed in terms of its properties, how better it is, how it can be defined. That is qualitative. And the one is quantitative, means you can define it with by means of length, weight, number or something like that, yeah, or categories. However, even qualitative variable can be generate numerical data. Qualitative variables also can be defined in terms of numerical data if categories are numerically coded to form a scale. For example, if you toss a single coin, the qualitative outcome could be recorded as 0 of a head and 1 if a tail. So the coin toss case, though we are getting head or tail from the coin toss, in that case we can redefine it in terms of some qualitative variable, in terms of some quantitative variable, sorry, in terms of some quantitative variable. For example, if we get, suppose here is the head and tail. We can define it 0 and 1. For example, we can also define something like if we just check out the people's eye color. In that case, we can define it. Okay, if we get eye color, it can be 1. If we get brown, we can code it 2. If we get eye color gray, then it could be coded as 3. So this way we can redefine it, or we can turn it into quantitative numbers or quantitative variables. Sometimes you may see that there this kind of variables for the color coding as well. Yeah, in remote sensing you will find it in several times or several locations that those color are coded in different number. Like red is getting one number and blue is getting another number. In terms of means those qualitative variables, those colors are changed into quantitative variables. And random variables are numerically valued variables. X will vary or change depending on the particular outcome or experiment being measured. For example, suppose you toss a die and measure X, the number observed in upper face. The variable X can taken in any 6 values 1, 2, 6 depending on the random outcome of the experiment. For this reason, we refer to the variable X as a random variable. Means if a variable can take any outcome after the experiment or in the experiment, then we can call it's a random variable. For example, if we just survey the height of the people, in that case, the height is a random variable. If we take any person in our surroundings, then height is a random variable. So a variable X is a random variable if the value that is assumes or correspond to the outcome of an experiment is a chance or random event. Means it is not occurred by purpose. It is just happening by chance, or it is not previously we don't know the exact outcome, but whenever we just pick the person or sample, in that case we are getting the value. That's why it is a random variable. So for those random variable, we can get the probability distribution, or we can get a lot of values for those variable, and we can arrange it in terms of frequency distribution, and then those frequency distribution can be described in terms of probability distribution as well. So the probability distribution for a discrete random variable, okay, here is another term arrived here. Here is discrete variable. Another one is continuous variable. Continuous variable are those which one can take any number. The variable that one can take any number, that is called continuous variable. Can you give any example? Can anybody give any example? Can you give any example that
Sir, age can be continuous variable, sir. Our age
is a continuous variable? Yes, indeed, it is a continuous variable. So if we survey the age of person in a city, then we can get any number. If we just think about the age, we will count the age in terms of second. We can get any number, or in terms of minute, or in terms of hour, we can get any number. Any other example? Though it have some ambiguity, that's why. Can you give any other example of continuous variable?
Sir, roll number of our class.
That is not continuous. That is discrete.
Sir, temperature.
Temperature, it can take any values within the range. So it is also a continuous variable. It can take any value. Suppose we can take 10.00000001 degrees centigrade. It is not a discrete number. It is a continuous number. Means it can have any values. Any other example? Hello?
Sir, time taken to complete a game, like doing race.
Yeah, that is time. Here, time, it is also a continuous variable. And anything else? What about height? Height of people, is it discrete or continuous?
Sir, continuous, sir. Sir, height and weight.
Weight is also continuous. Indeed, if we whatever the measured quantity we have in our surroundings, all the measured quantities are what kind of variable? Hello?
Yes,
Hello?
sir.
If you have any kind of measured quantities, those are continuous variable or discrete variable?
Sir, discrete.
Total mistake. Guns false. যে কোনো measured quantity, if you have any kind of measured quantity, all are continuous variable. Why I am telling this kind of things? Suppose you are measuring weight of a egg that is collected in a layer form. You are measuring the weight of egg that is having means it is getting it every day in a layer form. In that case, the weight of the egg egg is a discrete variable or continuous variable?
So discrete as because it is an individual value.
No, man. It is a continuous variable.
Sir, why, sir?
That's what the problem with our understanding. The problem is that whenever we are thinking about the variable, if that variable can take any number, then we call it is a continuous variable. Here the weight of egg. Yeah, we are just thinking about the weight of a egg. It can have any values. Suppose usually what will be the weight of a egg? For example, maybe 30 gram.
Yes, sir.
For example, it is 30 or okay, maybe more than that. Okay, take it 60 gram. Yeah. So the weight and whenever we measure a egg weight, we can get it 60.00003 gram. Then another one we measured it. It can have 60.05 gram. Am I right?
Yes, sir.
Another one can be have 59 point something. So it can take any number. So it can take any number or value. That's why the weight of an object is a continuous variable or discrete variable?
Continuous, sir.
Continuous variable. Anything. If you take any object, in that case, you can or you have this kind of or this variable can be termed as continuous variable. For example, if you just take if you weigh the mango, okay, you have a large farm, a mango farm, and from this mango farm you are measuring the weight of the mango to put it into the market, and the value of mango weight of mango is a discrete variable or continuous variable?
Continuous, sir.
It's a continuous variable. And can you give any example of discrete variable now?
So number of pages in a book.
Number of
pages in a book.
Number of pages in a book. It is a discrete variable. Why? Page number cannot be fraction.
Yes, sir.
Yeah, you cannot get page number like 212.0000 something or 212.5. You cannot get it. So it is a discrete variable. Any other example? Number of people.
Number of people participate in a game.
Yeah, it's a discrete variable. Number of plants in a quadrant. It's a discrete variable. Am I right?
Yes, sir.
Okay. So here we are discussing about the probability distribution of discrete random variable, not continuous random variable. We are talking about the discrete random variable. The probability distribution for a discrete random variable is a formula, table, or graph that give the possible values of x and the probability of px associated with each number of x. So this distribution give formula, table, or graph. This distribution can be expressed in terms of formula or a table or in terms of graph, and in those formula, table, or graph, that will provide the possible value of x and its probability. এটা কি কোন জিনিস থাকবে এখানে? কোন একটা x ভ্যালুর জন্য এটার প্রবাবিলিটিটা ডিনোট করা থাকবে। এটাই হচ্ছে প্রবাবিলিটি ডিস্ট্রিবিউশন। তাহলে একটা ডিসক্রিট প্রবাবিলিটি ডিস্ট্রিবিউশন কি করবে? এটা আইদার একটা ফর্মুলা হতে পারে, মানে সিঙ্গেল এক লাইনের একটা ইকুয়েশন হতে পারে, অথবা একটা টেবল হতে পারে, আদারওয়াইজ ইট ক্যান বি এ গ্রাফ that will describe or that will give you the possible value of x and its corresponding probability, that is the probability distribution. So the value of x represent mutually exclusive numerical event. The values of x represent mutually exclusive numerical event. Here in this probability distribution, the values of x represent mutually exclusive numerical event. Means there is no overlap with other event in that distribution. Summing up px means summing up the probability over all values of x. যদি আমরা এই x এর সব ভ্যালুর জন্য যে প্রবাবিলিটি যেটা দেওয়া আছে ওটাকে যদি আমরা অ্যাড করি, if we sum it up, then we will find their total value is equals to 1. That's why we will find that the probability range or the probability of x must be lie between 0 and 1, must be within the value of 0 and 1, and their sum, the sum of their probability is 1. So you understand this two term or two equation here, two condition. Did you understand that?
Yes,
Sir,
sir.
can you tell about the second one, sir?
The second one is actually describing this statement. The statement here is describing in terms of this mathematical form. The value of x represent mutually exclusive numerical event. Summing probability of x over all values of x is equivalent to adding the probabilities of all simple event, and they are therefore equal 1. So here is given. So here is there is toss 2 fair coin. You know coin here. If we toss 2 fair coin, let x equal the number of head observed and find the probability distribution for x. Find the probability distribution for x. If we get head, then it is positive or 1. If we get tail, then it is negative. So first experiment, or even one sample event. In coin 1, it is head, and coin 2, it is head. And x is 2. Second one, it is head. Next one is tail. The probability for this one is also 1/4. Here is also 1/4, and it is 1. Head is 1 time, that's why it is 1. And for the coin 1, it is tail, and then coin 2, it is head, then that's why it is also again, it's 1. And both of them are tail. In that case, it is 0. And if we sum up the probability of this 4 event, for this case, how much it is? 1/4 plus 1/4 plus 1/4 plus 1/4.
So 1.
1. And these things we can express it in terms of probability distribution. In terms of probability distribution, how we can tell it? For example, here, see this head and tail, head and tail. The frequency of this one, head or tail, is 2/4. And both of them are tail is 1/4, and both of them head is 1/4. So that is here, and we can express it in terms of this histogram. Did you get it? So here is one important thing. The standard deviation of sigma of a random variable x is equal to the positive square root of its variance. That things actually we know from your basic statistics, but it came up from the probability, the notion of probability. An electronic store sells a particular model of a laptop computer. There are only 4 laptops in stock. The manager wondered what today's demand for this particular model will be. She learns from the marketing department that the probability distribution for X, or the daily demand for the laptop, is shown in table here. Find the mean, variance, and standard deviation of X. Is it likely that the 5 or more customers will want to buy the laptop today? 5 or more customers will want to buy the laptop today. She wanted to find it out. So here, finally, the variance is described based on this. Variance is this one. The standard deviation is 1.34 and mean is 1.90. And how does this mean are described or came up? From this table, having 0 is 0 multiplied by the probability of that event, then 1 multiplied by the probability of that event, then similar way up to this, and they sum up and they got this one. Here is the example is given here. Here is the example. So I will move to the probability distribution directly. The discrete probability distribution. There is couple of discrete probability distribution we will be discussing in our course. One is most common one is binomial and another one is Poisson's. The binomial probability distribution. So a coin tossing experiment is a simple example of an important discrete random variable called binomial random variable. So doing the coin toss, that is the very common example of binomial probability distribution. Many practical experiments result in data similar to the head or tail outcome of the coin toss. For example, consider the political poll used to predict voter preference in election. Each sampled voter can be compared to a coin because the voter may be in favor of our candidate, a head or not, a tail. In most cases, the proportion of voters who favor our candidate does not equal half. That is, the coin is not fair. In fact, the proportion of voters who favor So here is some situation, coin tossing experiment kind of things. A sociologist is interested in the proportion of elementary school teachers who are men. So a sociologist wanted to find out the proportion of elementary school teachers are men. So that is his intention or study topic to find it out. That's why it is binomial. Can anybody tell me? Are you there?
Yes, sir.
So how this event can be a binomial? Means someone trying to find out that what proportion of elementary school teacher are men. As that person is wanted to know what proportion of people are men. So if he find a man in suppose he went to the school, then start to find out, take the sample one by one. Then if first one he interviewed, then if he found that teacher is a woman, so in that case he will tally it is not a man, so it is 0. And if he find the person find the sample as man, then he will tally it 1. Okay, so whenever he will find a teacher is a man, in that case he will tally 1. And whenever there is nobody, that sample is other gender, then it is 0. So that's why it is a binomial case. Or that's why it is a binomial experiment. A soft drink marketer is interested in the proportion of cola drinkers who prefer her brand. So one of this marketing officer wanted to find out that the people who are drink cola, means the black drink, in that case, how many of them are choosing, or what proportion of them are choosing their brand. Like somebody wanted to know, okay, among the cola drinker, what proportion of people are drinking Pepsi? Okay. Is it a binomial case or not?
Yes, sir. Binomial.
It's also binomial, because in that case, if somebody is telling, okay, he or she drink Pepsi, then it is 1, means positive. And if somebody says, okay, I drink Coca-Cola, I drink RC Cola, yeah, or other cola, then those are 0. That's why it is a binomial case. A geneticist is interested in the proportion of people who possess a gene linked to Alzheimer's disease. That is also a binomial case. Who possesses a gene link to Alzheimer's case. So whenever he will be doing the interview, then he or she will ask the person or the sample that whether in their family they have any Alzheimer's case disease or not. If they say yes, then it is 1. Then it is, if somebody says no, then it is 0. Then gene link in other family members also interviewed similar manner. So definition of binomial experiment is one that has these 5 characteristics. Did we discuss this one?
No, sir.
Okay. A binomial experiment is one that has these 5 characteristics. The experiment consists of an identical trial. The experiment consists of an identical trial. For example, suppose we wanted to find out the people who are interested in cola drink of certain bread. Yeah, in that case, we will choose the cola drinker of within a community. Then we will do the experiment. Maybe we can select 1,000 people from our Chittagong University, and then we can do the experiment whether they like the RC cola or not. For example, our experiment is on RC cola. Called success as another one is named as failure. The probability of success on a single trial is equal to P, and that remain the same from a trial to trial. The probability of failure is equal to 1 minus P or Q. The trials are independent, means if we take out one person and ask him, okay, you like RC cola or not? Then he said, no. Then I picked the second one. Then he also said, no. So what, either we may infer that, okay, the previous person have a link to the second person. But in our reality case or in our study case, it should not have any kind of link kind of things, or the trial should be independent. Means the first person outcome should not influence the second person's outcome. We are interested in X number of success observing during the end trial for X equals 0, 1, 2 up to N. So here is one nice example is given, and that example is described in terms of how this example is a binomial experiment. Here it is described based on these 5 properties. Okay, based on this, discussed based on these 5 properties or 5 characteristics. Here it is 1 by 5, it is described. So you should read it. And then an example is given here. Again, considering the same phenomenon. And at the end, if we wanted to know the binomial probability distribution, Then the probability of K success in n number of trial. K success means, okay, if we wanted to know, okay, if we wanted to know, for example, if we wanted to know in our trial, okay, we wanted to find out that when we can get or how we can get 30% success. Yeah, do we have a chance to get as 30% yes outcome from this probability distribution? That can be studied, or that can be enumerated or measured by using this formula. We wanted to know, suppose we are having trial for 100% whether they like the Arsicola or not. Yeah, and we wanted to from this population 100%, we wanted to find out, okay, how many, what is the chance of getting 30% is liking our Arsicola? What is the chance? Yeah, so here is K equals how much? K equals how much? We wanted to know, okay, what is the chance of getting 30% favor our Arsicola or favor our Arsicola? So here K equals 30. And for the probability of getting 30 is denoted by this equation, equals combinatorics of n by k and k, p power k, q power n minus k. And we can break it down into this. For example, in our case, in this case, we may assume that, okay, there is a chance, p chance is 0.5 and q is how much? Chance of getting a choice of Arsicola. So here is P is 0.5. So Q is 1 minus P equals 0.5. Then we want to know X equals 30 people when we sample 100 people. When we survey 100 people, in that case, what is the chance of getting 30 people? They will like our RC cola. So, do you get my point or this question?
Yes, sir.
So here the probability is P. We can describe it X equals K. X equals K means X equals is 30. That equals. So here N equals how much? N is number
100.
of sample or number of identical trial. How many trial we are doing?
Sir, 100.
100. And K is 30.
Yes, sir.
And N minus K, it is then 70. P to the power 30. Q to the power 70.
70.
And P is how much? 0.5. Q is 0.5. So in that case, we will get the probability of getting 30% in the trial who will like RC cola. Okay. What is the answer? Can anybody tell me what is the answer? Are you there? Hmm? Do you have answer? Any answer? কেউ কি করছো? আমাকে চ্যাট বক্সে আনসারটা পাঠাও। পেয়েছো কি আনসার? Do anyone have answer?
Sir, I'm doing, sir.
বাকিরা কি কেউ নেই? One two two. 182082122 কে আছো? এটা কে? প্রত্যেকে আমাকে আনসার লিখে পাঠাও, each of you. কেউ কি আনসার পাঠিয়েছো?
স্যার ফ্যাক্টোরিয়াল দা করলে স্যার ম্যাথ এরর আসছে স্যার ক্যালকুলেটরে। স্যার আমি যখন স্যার এন এর ভ্যালুটা পুট করলাম স্যার 100, তারপর স্যার কে দিলাম স্যার 30, তো স্যার তখন ম্যাথ এরর আসছে স্যার ক্যালকুলেটরে।
তাই নাকি? কেন আসবে? হ্যালো,
জি স্যার।
did you try? So here is n is 100.
Yes sir, 100 factorial.
100 factorial and k is 30
factorial. Yes sir.
And n minus k is 70.
70 factorial.
So 30 and 70 factorial. So from here it is 70 is done.
Yes sir. Then into 0.5 to the power 30.
Yeah.
And 0.5 to the power 70.
Yeah.
Yes sir. So after giving equal to sir, it is coming sir math error.
So where is the problem? Okay. Shift and see. Shift. Hundred. Shift. This. Then 30. Multiplied by 0.5 x. x power x power, where it is. What is x to the power?
X to the power. And this is it. No, it is x2. It
No.
is x to the power.
This calculator is not. I just lost in here. So it is math error, yeah, somehow. I don't know why. Okay,
Sir, is there any other formula?
No, there is no other formula. We can check it in somewhere with other example. So here is one example. Find p x equals to for a binomial random variable with n equals 10. Total number of trial is 10 and p is 0.1. So q is how much? 0.9.
Yes, sir.
So here we got these things. So p equals x equals to equals C 10 by 2, 0.1, then x is 2 and 0.9, 10 minus 2. 10 is the n minus k. Here is 10 minus 2. This way they find out here 0.1937. Is it working, this one? Did you check it that whether this one is working or not?
Sir, I'm checking, sir.
Please check it whether.
Yes, sir, this one is correct, sir. Sir, it shows the same value, 0.19371.02.
So 45 multiplied by 0.01 multiplied by 0.43046. Yeah. I got the point now. Here is 10. F2 equals. Now it's okay. This one is correct. But in our previous argument, why it is not correct? So that one is 100. Into 0.5 power 30 into 0.5 power 70 equals. Yeah, now I got the previous one result. That one is actually 2.317 10 to the power minus 5.
Sir, did you change any value?
No, that one is not math error. Actually, maybe whenever you try it together with the combinatorics value, that times it is coming some math error. Maybe you are not putting multiplication properly or something like that.
Maybe, sir.
So there is some other problem is there. There is one problem is here. This one, example 5.4. You should try it. And try this exercises. Yeah, exercises 5.2. There is a lot. So try to find out up to 5.13.
Okay, sir.
Up to 5.13. Okay, that's today. And tell me if you have any problem while solving this those mathematical simple operations.